Let's make sure our phones are away and we're paying attention. Put your laptops down so you can focus, please. Okay, so like Jacob asked, is this one of those if you group first two and last two? It is. There's no GCF for all four. Remember, these are polynomial equations we're solving, and we have to factor all of them. Okay? So to factor again, it's a grouping problem. So we're going to group first two, last two. Since that had a negative in front of the 8, we're going to make it, or put it in the group and just put a little plus sign between them. And then we take out GCFs. So the GCF for this group is x cubed. And then you get x plus 3. And you divide x to the 4th by x cubed, and 3x cubed divided by x cubed. Since that's a negative there, we always pull that negative sign out. Okay, if that's there, even though, they're both negative this time, but sometimes that's a positive, you still pull that negative out. That's important. And 8 goes into both of those. And then you get x plus 3 again. So you got this x plus 3, and then the x cubed minus 8. Okay? Now this one is what we call a difference of cubes. 8's a perfect cube, and x cubed is a cube. So I actually got to go a little further on this one. It's one of those binomial trinomials. Oops, that's equal to 0, right? It's an equation we're solving. So we take the cube root of x cubed and the cube root of 8 for the binomial part. And then the trinomial part, we go x squared. Since that's subtraction, this middle one's addition, they're always opposite signs. And then I just multiply those, x times 2. And then I square the 2, and this is always addition here. So that's a 4. So now it's all factored. When we do a difference or sum of cubes, this trinomial isn't factorable. There's no factors of 4, 1 and 4, 2 and 2 that add up to the 2, the middle one, right? So I have to solve this one like we did last week using the quadratic formula. Okay? So I got my 3 factors. I got to set them all equal to 0 for this. Something times something times something is 0. One of those 3 factors has to be equal to 0, so I solved each of those equations. All right, you guys are getting to the point you should be able to tell me that answer is negative 3. And this answer is positive 2. Right, you're going to subtract 3 from both sides, add 2 to both sides. All right? And then use that quadratic formula to finish that one. All right? So negative b plus or minus b squared minus 4 times a times c. Right, Connor? Over 2a. All right? This problem's got quite a bit to it. But again, nothing new for you guys. You guys can handle this. So 2 in the bottom, negative 2 there. And then we're going to figure out what's there. So 2 squared is 4. And negative 4 times 1 is negative 4 times 4 is negative 16. So that's a negative 12 that's in here. All right. Well, 12 I can break down with a factor tree. And the 4 times 3. Right, Nathan? So there's a perfect square in there. So I can pull out the number 2. So I get negative 2 plus or minus 2. Since it's negative, I, the square root of 3, all over 2. So math, what do I got to do with those 2? Yeah, divide them out, reduce it. Morning, Brady. You run out of gas again? Not this time? The truck's still running? Surprisingly, yeah. Well, that's good. All right, so like Matt said, I got to divide 2 into all of those. So my final answer there for that one is -1 plus or minus 1i, or just i, square root of 3 over 2, or I'm sorry, over 1, which we don't need to write over 1. So there's 4 answers. Remember, we talked about this yesterday. If the degree is 4, that first term, its exponent tells you how many answers there should be when you solve it. Okay? So we had 2 real answers, -3 and +2, and then 2 non-real answers, for a total of 4. Okay? So that had was a grouping problem, but then it had a difference of cubes, which we reviewed again yesterday. Nothing new, but it had some work to it. But I expect you guys to be able to do that type of problem. Okay? Any questions? Okay, some of you, looking at your submissions, didn't factor. And we just tried to get that x alone. And when you got a couple x's in there, you can't get it alone. We've got to factor first. All right, so let's make sure we're factoring when we're supposed to on that. All right, so we did the odd ones, right? 1 through 11. So number 1 had 3 answers, 0, 5, and -5. Number 3 also had 3 answers, 2, 1, and -1. Number 5 had actually just 3, but I think the 0 worked, let's see, 3 times. Yeah, it actually works 3 times, but that we don't have to worry about multiplicity right now. So 0 was one of our answers. It worked multiple times, and then +3 and -3. Number 7 was 0, -5, and 8. 0 worked a couple times. Number 9, 0, +4 and -4. 0 worked a couple times. And then number 11 was this problem right here, actually. That was this problem. So it's 2, and then the -1 plus I radical 3, and the -1 minus I radical 3 was the 3 answers for those. Did you want me to go over any of those? Tanner, makes sense? Since you weren't here yesterday. Okay, so factoring, which is nothing new. Once you got a factor, set your factors equal to 0 and solve for x. Okay? So that was, we talked yesterday, I told you there's 4 different ways, so these different equations, 4 different types this week. So today, the second type is rational equations. Okay? Which means fractions. All right? So when we did the fractions before, I know that you guys don't like working with fractions, right? So the first thing we did was try to get rid of the fractions. That's the easiest way to do these. Okay? So we have to talk about a what? What do you think? Well, it's kind of a GCF, but we don't call it a GCF. Yeah, least common denominator. Okay? We want to get rid of the fractions right away so that we don't have to work with them, okay, as that much. So we're going to multiply the whole equation by the least common denominator, okay? So when we were doing least common denominators before, we were trying to factor denominators if we could. Can I factor any of those 3 denominators? I can. So what did we do if we couldn't factor them before? When we did addition and subtraction of fractions, we had to get a common denominator. If we couldn't factor them, or even if we did factor them, what did we say? Whatever shows up, Marcus, Hannah, very good. We wrote it down. Okay? So, an x minus 1 shows up and an x plus 7 shows up, so I have to write those down as my common denominator. Okay? So, the same rules we had before. So, we're just taking this whole equation, both sides of it, and we're going to multiply by both of those denominators. Okay, but what happens is when I multiply these two binomials times this fraction, what happens to these two things? They'll cancel. So basically it's just 4 times x plus 7. That x minus 1 goes away. No more denominator. Here, what goes away? The x plus 7. So all I got to multiply the 7 by is the x minus 1. And that fraction is gone. And then on this side, again, the x minus 1's canceled. So it's the 5 times the x plus 7. So if you think about it, it's basically the numerator times the other denominator. So the 4 and the 5 went by the x plus 7, and then 7 went by the x minus 1. That gets rid of your fractions. So now it's an equation that you guys can handle a little bit easier. Okay? So Michael, what do I do with this 4 and 7 and 5? Right, we're going to distribute them. Okay? All right, so we got 4x plus 28 plus 7x minus 7 equals 5x plus 35. Questions so far? Does that make sense? Thank you. All right, combine like terms here on the left, so it looks a little simpler. 4x plus 7x is 11x. 28 minus 7 is positive, 21. So now it's looking a little bit easier. Okay? You with me, Reynolds? All right, so now I got to get the x's together. Okay, they're on, one's on each side, so we get them together. It doesn't matter which side. I'm going to take the 5x from the right and move it over to the left, so I have to subtract it. I'm also going to take the 21 over to the right, because I want to get x alone. So I'm going to subtract it. So I'm doing basically two things at once. Move this down. All right, so the 21s cancel and the 5s cancel. And I get 6x on the left. And what's that? 14 on the right. Yeah. And divided by 6. And, we're not always going to get a whole number. That's okay. I'm going to reduce that, divide both those by 2. So 14 divided by 2 is 7. 6 divided by 2 is 3. If you want to write 2.3 repeating the decimal, that's okay. Now on these, okay, on these rationals, you always got to check the original problem. Because what are we not allowed to have in the denominator? What are we not allowed to have the denominator equal? a 0, right? So you always check these. If your answer, whatever you get, when you plug it back to the original, gives you a 0 in the bottom, you can't use it as an answer. Okay? But, no. 7/3 minus 1 is not 0. 7/3 plus 7 is not 0, so I'm okay. If I would have gotten a 1 or a -7 as an answer, I wouldn't be allowed to use it because that would give me 0 in the denominator. So you always have to check these. Do we check them once? Just one of the problems or all of the problems? All of them, Matt. All of them. Cam, all of them. All right. Workman, don't zone out on me, okay? I know you're thinking about winning the Federal League this weekend. But right now, before you can win the Federal League, you want to ace. Well, we don't have a quiz Friday, do we? You don't have to worry about a quiz this week. All right, this one. Same thing. What's my common denominator? X minus 5. It's the only one that shows up, right? So that's what you use. So, remember, I multiply everything, the whole equation, all three terms, by x minus 5. It's the only denominator that shows up, so you just write that one down. What happens to these two x minus 5? They cancel, so all I have is x. All right, what's 1 times x minus 5? X minus 5, so don't forget that you got to do the 1 times that. And what happens to the x minus 5s here? They cancel again, so it's just minus, see that's a minus, so it's minus 5. Okay, so the left is x. Okay. So now what? Brooke? Yep. I want to get this x over here with this one. So what happens here? Yeah, now when these cancel out, what's left? 0, right? There's no x anymore. Is this a true or a false statement? It's a false statement. So what do we say the answer is? No solution. That could happen. Okay? What if I got 5 as an answer? What would we say? Justin Rhodes. What if we got 5 as an answer for this problem? All right, what if it said x equals 5? What are we always supposed to do? Check. If I put a 5 there, what happens? What do you get in the bottom? 0. Would that be okay to use? No. We'd also say no solution. Remember, check. All right? So everything works out nice. You get x equals 5, then you plug it into the original. You get 0 in the denominator. No good. No solution. That make sense? Okay. If I got a true statement here, what if it said -10 equals -10? What's that telling you? Yeah, all real numbers. Anything works, right? That could happen too. All right? All right, one more example. What do we call it when there's a fraction equal to a fraction? Starts with a P. R. O. proportion, right? How do you solve proportions? Cross multiply. So when you see one like this, where it's just one fraction equal another fraction, all right? Cross multiply. It's a proportion. So it's going to be x times x plus 1 equals x minus 5 times x plus 7. All right? So then I'll distribute. Renita, what's this equal? Good. Z, what's this one equal? What's this equal when I multiply?
X squared minus 140. No, it's 45.
All right, but that's
Negative 35.
right. That's those, right? But what else do I have to multiply? Remember, we got to do what do we call this?
Oh, yeah. 4.
Yeah, we got to FOIL this. So what's that? Those two,
Then 7x
and then these two,
minus 5.
right? So we have to FOIL that. Okay. So then, if I simplify over here, the left side doesn't change, but the right side I can make these two into 2x. Connor, what should I do now? Tanner.
Combine like terms.
Yeah, get the things together, right? We got things that are like on either side. We got to get things that are like together. So what do you want to do first, Tanner?
Subtract x squared.
Yeah, bring this x squared over. What happens to them?
Equals 0.
Yeah, they go away, right? So now I got this. Go ahead, Tanner, keep going.
Subtract 2x.
Right, get the x's together now. Now, if the x squareds don't go away, which could happen, if I bring the x squareds together and they don't go away, then I have to set it equal to 0 and solve it as a quadratic, which could happen. All right? So if the x squareds don't cancel like this, 1, set it equal to 0, and then I would just use quadratic formula. Don't worry about factoring or any of the others. Usually that's the one you guys are best at. So, am I finished? No, we got to do, finish it up, Ken.
Divide by negative 1.
Right. So we get 35. Negative divided by negative makes it positive. Now, again, we're supposed to go check the original. So go back to the original. We got 35. Oops. Started moving on me. Okay. Will I get a 0 in the bottom if I put 35 there or there? No. So is 35 okay? Yeah, that's okay. Remember, always check. Make sure it doesn't give you a 0 in the denominator of the original problem. Okay? So, these are called rational equations. Okay? That means we got fractions. That's what a rational number is, a fraction. To get rid of your fractions, that's what you want to do first, is multiply everything by the common denominator. Then you'll get rid of them, and then you just do things like you're used to doing. Okay? So, if you can't factor them, which I think most of them you can't, you just write them both down, or all three, or whatever, however many there are that they show up once, write it down, and then multiply through. Okay? If there's only one, write it down. Okay? Multiply through. Okay? If it's a proportion, cross multiply. There's your assignment. 6 problems. Okay? Let's work practice. Okay, again, next week will be our last quiz for this 9 weeks. It'll be Wednesday next week. All right? So make sure we're focusing and finish strong this 9 weeks.